Hi there. In a recent video, I showed you how to take 3 impedance measurements that are required for upload into Speakerbench. So today I'll show you how to upload those measurements to compute a fit, create a data sheet, and so on. So first, let's look up that data. So here it is, 3 measurements. With unweighted driver with half the added mass and the full added mass. So let's go to speakerbench.com and click on collect data from measurements. So we add the unweighted driver there, the 2 added mass measurement there, and the full or 4 added mass measurement there. They're still not quite done. So we've uploaded all the ZMA files. These are quite large files, but we still have to enter the individual masses and optionally a voltage. So let's enter those masses, 5.824 grams and 11.53. And even though it's optional, I'll add the voltage, 250 millivolts. All right, and it's created a JSON file for us that really merges together these 3 measurements, the 2 mass levels, this voltage, and it would also append a comment to that file if I'd entered it there. So let me save this. All right, so this is the so-called Speakerbench Z file that contains all the impedance data. Now we can move to the Fit tab. So in the Fit, we just have to drag that file, give it a few seconds. It's a complex calculation. All right, so it gives us a fit quality. The first thing you should look at is the fit quality. It gives a kind of objective rating of the quality. This one says it's excellent. I won't explain too much more than that. Let me just go through the different tabs. So these are the calculated fit parameters. This is the fit impedance of the unweighted driver. This is the phase. The impedance is a complex function, so it has a magnitude and a phase. I won't really explain what this is other than to say it's the motional impedance. There's an equivalent electrical impedance. This is probably the most important tab to look at to gauge the quality of the fit. It shows the fit not only for the bare driver, but also how well the model performs when applied to the weighted drivers. Sometimes you'll see in this case that the unweighted driver fit is quite good, but the fully weighted driver is quite bad. But not in this case, everything looks good. And also the BL, this is important that the BL be constant inside this pink region. Again, I won't really explain in too much detail what these plots mean. You can focus on the excellent rating. And now let's save this file. This is the so-called advanced file, but it doesn't contain everything we need. So let's go to the datasheet tab, and I can drag this advanced file, which contains all the calculated parameters, but we really should enter some descriptor data, and we need to enter one more physical parameter of the driver. So this is SB Acoustics driver, and the model number is there. For comments, I'll say measured with the woofer tester pro. I'll skip the manufacturer. We can just put, you should always put your name there. It auto fills the date and the voltage and the current git hash of the Speakerbench app. There's some default. If you're measuring in very extreme environment, if you're measuring in very hot or very cold temperatures, you can update those numbers. Now, all of these parameters have been auto-filled. The advanced and then equivalent simple parameters. Go back here. You'll notice this red tab is the required radiating area of the cone, which you can just look up on the manufacturer's data sheet. And in this case, it's it's 82. Whoops, it's 82 centimeters. It will, now you have to click apply. 82 square centimeters, which is equivalently a driver diameter of 102 millimeters. It will do that conversion for you. All right, so now if we go back to the general tab, we see that there's a so-called Speakerbench data file here, which is the full data sheet that we're interested in. So we can save that. This is the I would say the ultimate parameter file that really contains everything you need to know about the driver. Now also in Speakerbench we can transition seamlessly to a box simulation tab. So I just carried that data over to the box simulation tab, and you'll see it says here it's the SB Acoustics driver. I just typed that information in. It auto guesses, these aren't necessarily clever guesses, it just chooses a box volume that's equal to the driver VAS, and it chooses a port tuning that's equal to the driver resonant frequency. These are sort of ballpark values. Then we can look at the SPL of the, here's the cone and the port SPL. Here's the total box SPL. The impedance of the driver in that vented box, the driver excursion, the vent velocity, the group delay. Now there's a step function, but it's not active because it's actually complicated to do the time domain calculation. So let me just go over here. I'll increase the number of points that we do the calculation with, and I'll click on the time domain toggle, and I'll redo the calculation. Now it takes longer because of the time domain calculation. Then I'll go back here. Now you see there's a step response computed, and also down here we have effectively the poles, and well, we have the contour plot of the transfer function. The transfer function is a complex function, so this is just a plot of the amplitude of the transfer function in the complex plane. All right, you can go back here and tweak these settings to your liking. You can adjust all, the usual parameters you would adjust to do your box modeling. All right, I think that's everything.